Today we're going to be solving absolute value inequalities. And the way we're going to do that is isolate the absolute value symbol here. So first thing we want to do is undo this addition of 1/2. And the way we do that is we take away 1/2 from both sides. And when we do that, still left with this 3 being multiplied by the absolute value of x. It's still greater than, but now when we take 1/2 away from 6.5, we're just left with 6. Well, we've got one more step. We have to undo that multiplication. So the way we'll do that is we're going to divide by 3. That will cancel out these 3's. Do the same thing to the other side because that's what we have to do to keep inequalities or equations in balance. So we're still left with this absolute value of x, and it is now greater than 2 when we do that division. So let's take a look and try to understand what's going on here. See, if we had numbers that can go in for x that are greater than 2, we're thinking of numbers like this. If we had, let's try 3. So if we took the absolute value of 3, that is greater than 2. The absolute value of 3 is 3, which is bigger than 2. We could also do -3. So if we took the absolute value of -3, that's also 3, and that is greater than 2. So the values have to be either bigger than the 2, bigger than the positive number, or smaller than -2. And that's what we're going to end up doing. We're going to end up taking that x, and we're going to set it greater than 2, but less than -2. And when we do that, we go ahead and graph it, and you'll get a better representation of this. So if we put 2 and -2 in their respective spots, on the number line we'll draw open circles to represent that those are not solutions but just endpoints. And when we read this off, x is less than -2 because it points towards the x. So less means left. And so we're going to draw the line to the left side. So the answers, the values that work for x are like -3, as we said, -4, -5, -6. They're all the numbers to the left or smaller than -2. Looking at the other inequality, though, x has to be greater than +2. So those numbers are like the 3, the 4, the 5, all the numbers that are bigger. So this is a disjunction, or an OR statement. And so since it's an OR statement, we have to write this as two separate inequalities. So we're going to write this inequality first. X has to be less than -2. Now, I just took this portion of it right here, and I rewrote it. But remember, I put the x on the left-hand side of the inequality and the -2 on the right side. So I had to switch the inequality to make it match what it said up here. Now we have to use the word OR, because again, the values of x work with one inequality or the other, not both. And then I put the x here, and I matched this part right here. X is greater than 2. So open to the x with the 2. So this is the algebraic answer. And then we also have the graphical answer above. Well, let's take a look at one more like that. Number 2. Say it was, how about a x plus 3 inside some absolute value bars. We'll go with a plus 2 and 1/10 is greater than or equal to, and we'll go with a 3 and 1/10. So first thing to do is we need to isolate this absolute value, just like we did on the last part. Here we had to subtract 1/2. Well, over on this other problem, we've got this 2 and 1/10 we have to deal with. So we're going to do the opposite of 2 and 1/10. We are going to subtract 2 and 1/10 from both sides. So when we do that, still left with that absolute value. And now we are going to have it greater than or equal to. When you do this subtraction, these 1's cancel out. We're just left with 1. Well, now we've got the absolute value isolated, just like we did over on this stage here. So we don't want to subtract 3 now because it's inside the absolute value bars. So we're ready to set up our problem. We can set up x plus 3 can be greater than or equal to 1, but it could also be less than or equal to -1, because this will end up being an OR statement. So it's always going to be, the answers for x are going to be bigger than the one endpoint, but smaller than the other endpoint. So from this stage, we have to now move that 3 over. Once we've limited the absolute value bars and set it greater than the positive and less than the negative. So we'll go ahead and subtract those 3's from both sides of this inequality, and what we're left with is a -4. Now I had to add those two numbers because they are both the same sign, is greater than or equal to x, but it is also x is greater than or equal to -2. And I had to subtract these because they're opposite in sign. The one further from 0 determined the sign. So we're ready to graph this. So we go ahead and place the -4 on the left and the -2 on the right, and this time we're going to use solid circles because -2 and -4 are solutions because it equals those numbers. But we also have the inequality as well, so when we read this, read from the variable to the number, x is less because it points to the x is less than or equal to -4. Less means left. And then I also have an x is greater than or equal to -2, so I have to go to the right. And then from there I can rewrite my inequality. I've got x is less than or equal to -4, or x is greater than or equal to -2. And that is our solution. So the next type of problem is going to be an AND problem, and we'll see that in part 2.